Hello and welcome to this new episode of our lessons on factorization. Here we will be taking a look at various aspects of factorization, the basics, and how it's cut across many topics in mathematics. Now, factorization is a very important topic since it starts from the basics to the advanced. So you need a very vast knowledge of factorization for you to get stuck in some of these stuffs in mathematics. This episode is divided into 5 units, as you can see on your screen. It's most likely going to be that we have more than 5 units group of lessons. So now let's see how it's going to be. In our unit 1, we'll be considering factors of numbers. Now in unit 2, we'll be taking a look at factorization of simple expression or large expression, algebraic expression in algebra. Now in our unit 3, we're taking a look at factorization by grouping of terms. Like maybe you need to group terms into 2 or 3 different groups. And in our unit 4, we'll be considering numeric application of factorization, like the use of real number. When we get there, you understand. And in our unit 5, you will be considering past questions. So that unit 5 can lead to several other units depending on you guys. So there may be a need for me to or for you to just send any work across that you're facing one challenge or the other in your factorization work in school. So under this unit 5, we're going to do as many questions or solving as many questions as I can receive from you guys. So I thought I tell you this topic you're going to enjoy. So we're going to be having each of these units in different videos, at least a video per unit. So you can have some units in more than a video in case I have a lengthy stuff to discuss with you and I wouldn't want to bore you with one long video like that. You understand that? So you are welcome and just sit tight for the lesson. Alright, for our unit 1, by the end of the lesson, factors of number. So students are expected to define what the factor or the factors of a number is. So we'll look into that. And number 2, we'll find a complete list of factors of a number. So there is a techniques around finding a complete list, not just some, but a whole, like a full list, not missing out any. So the third one will find a common factors of 2 or more numbers. So this can also lead us to finding highest common factors of 2 or more numbers. And lastly here, yes, just finding the highest common factor, just like I said earlier. So these 4 objectives are what we're going to be covering, and let's see how we're going to accomplish this probably in the next less than 40 minutes. Alright. Right now, for factors of numbers, we'll take in the first objective, defining what the factor of a number is. So the factor of a number are whole numbers that divide into that number without the remainder. Okay, let me just simply explain what I mean. Now, for instance, the factor of 18 are as follows. Just like you see them coming up on the screen, you say 1, 2, 3, 6, 9, and 18. What does that mean? It means that any of these numbers here, this 1 can divide into 18 without a remainder, 2 will divide into 18 without a remainder, 3 divides into 18, 6 does the same thing, likewise 9, and 18 itself. So all this list of numbers divides into 18 without a remainder. So that is just all about factors of a number. Now see, these are complete list of factors of 18. Complete list of factors of 18. So now with that done, let's take a few examples. Now we want to find the factors of the following numbers. So first example, let's look at The factors of 24. Taking a look at the factors of 24, let's use what we call the paired factors system. So, how do we go about that? So let's have a list of numbers that is popping up on our screen now. Having a list of numbers from 1 to 10. So, the first question you ask yourself is, this first number, which is 1 a factor of 24? Yes or no? If your answer is yes, so no problem. You pick 1, just like you see 1 here. You pick 1, then how many times does it divide into 24? I guess it's 24 times. So 1 divides 24 times. So that's 1 by 24 gives 24. Now, the next number is 2. Now, you ask yourself again, does 2 divide into 24 without a remainder? That's how you keep asking yourself. If your answer is yes, then you select 2. And 2 goes on there. Then multiply it by 12. So it means that 24 divided by 2 gives 12. Now, the next thing is, consider 3 as the next number or your next factor. Does 3 divide into 24 without a remainder? Yes or no? If your answer is no, you don't select. Now, we've yes for 1 and yes for 2. But now, for 3, what's our answer? Is it still yes? Of course, yes. So, 3 multiplies, or 3 divides into 24. How many times now? I think 8 times. So, that's 3 by 8 gives what? 24. The next number on our list of numbers is 4. You want to ask, does 4 divide into 24 without a remainder? That's a question you ask yourself. Does 4 divide into 24 without a remainder? Yes, it does. So that's 4. Now, how many times does it? That's 6 times. So you see 6 popping up. So after 4, you have 5. Okay, so the next question is, does 5 divide into 24? Question. If your answer is yes, you allow 5. But my answer is no. 5 doesn't divide into 24. You will usually have a remainder or a decimal or a fraction, whichever way. So I will get rid of 5. I don't need 5. Now the next number on my list is 6. Okay, the question is, does 6 divide into 24? I think yes, it does. 6 does divide into 24. Now how many times? That's going to be 4 times. But now I will need to stop because the 6 I want to use here is already appearing on this other side of my list of numbers. You know, these are the numbers I've been using. I've not been using this. So the division of these numbers are the one generating this. So one of my generated numbers has now become what I'm tempted to use or what I want to use now. So which is not allowed. So 6 is already here on this side, and because of that, I'm not permitted to use 6 again. Okay? So in that system or in any situation like this, that means I've come to the end of the list of factors of my numbers. So what does that mean? That is all the list of numbers that can divide 24. So with that, I will just need to get rid of every other number. I won't be able to continue just because of what happened. Now, I need to write out the list of numbers, factors of 24. So I will need to start from the 1, 2, 3, 4 here on this side, just like you can see them. Then I will also need to pick it from 6, 8, 12, and 24. 6, 8, 12, and 24. I just want to believe that is clear. Now, all this list of numbers now will divide into 24 without a remainder. And I want to assure you this is a complete list of the factors of 24. Why? Because of the paired number system that I used. That is what helped me to get a full list. Because many times you get factors, you may be told to look for factors of numbers, and you may skip out some because you are not using the right strategy. So let's go for example B. I'll be a bit faster. Now, we need to get a pair factors of 36. So starting from number 1, I'm making a list of 1 to 10 again. Starting from number 1, does 1 divide into 36? Of course, 1 divides into any number. So that is 1 and 36. Now, 2 is there. I will ask, does 2 divide into 36? Of course, yes. 18 times. Does 3? I think yes. 12 times. 4? Yes, 4. That's 36 divided by 4 gives 9. Okay, does 5? No. 5 doesn't. You can confirm on your calculator 5 doesn't. You will get a decimal. So I get rid of 5 again. Now, 6 is there. Does 6 divide into 36? Anybody? Our answer is yes. So 6 goes into 36 6 times. Imagine. So I'm multiplying 6 by 6. So 7, 8, 9, 10. Any other thing? Oh, nothing. Okay, now there is a trick here. Now I'm getting 6 and 6 here. It's another indication that I can go further. It's an indication that I cannot go further than this. I'm having 6 and 6 already, so I can't go further. Yeah, I can't go further. So I will need to get rid of the number of my list. So trying to get the factors of 36. How am I going to get that? I've gotten them already. Make a list of 1 to 6. Okay, 1 to 4 first. Now, I'm having 2 6 already. I will need to pick one of them and just ignore the other. This time around, I'm starting from 9 up. I'm not taking the second 6. So that's going to be 9, 12, 18, and 36. So with this done, I've been able to get a complete list of factors of 36. I believe that is understood. It must be understood. And the last example here, C, that's 60. So I need to get pair factors of 60. Now I need to make a list of numbers from 1 to 12. Now 1 to 12 now has 1 and 60. Now 2, the 560, that's going to be 2 and 30. Does 3 divides? Yes. 3 and 20. 4 does. That's 4 and 15. Does 5? Yes, 5 does. That's 5 and 12. 6? Yes, I think 6 and 10. Okay, now, so the next number on my list is 7. 7 is not a factor of 60. Check in your calculator, you have a decimal. 8 is also not a factor. 9 is also not a factor. Just confirm those 3 numbers, they won't give you a whole number. Now, 10 is a factor, but 10 is already on this side. So I can't use it here again. I can't use 10 here again. 10 is already on the other side. So that shows I can go further. So getting rid of all these numbers on my list. So let's bring out the list of our numbers from 1 to 6 first. So we have 1 to 6. Then from 10 to 60. So this list of numbers makes the factors, all the factors of 60. All the factors of 60 are here. So this peer system helps me get a complete list of factors of numbers I am looking for. Alright, I want to believe that is understood. And if not well understood, you can go over it again. Okay, now let's move to highest common factors of numbers. So we've been able to find the factors of 24 and 36. If we go back to our previous examples, if we know that the previous example is not well understood, go back there and spend a little time. You will get it. They are not that hard. You may just need to pay a sacrifice of time. Okay, now we want to get the highest common factors of 24 and 36. How do we go about that? So this 24, writing out the list of factors of 24. Using the paired factors number. So we're having 1 on 24. I believe this is not strange. That's 1 multiplied by 24. That's 24. Okay. That's 2 multiplied by 12. That's also 24. Then the next number is 3 multiplied by 8. That's also 24. You see the pairing system. And now, I think 4 and 6. 4 multiplied by 6. That is also 24. Now, just from this previous method I used, I've been using the same thing, the pair system, and this is the list. This is the last pair of number I can have. Now, 36. For 36, I have 1 and 36. Then 2 also divides 36, that's going to be 2 by 18. 3 also divides 18, that's 3 by 12. 4 does, that's 4 by 9. And I will have 6 by 6. But I don't need to write 6 twice. I just need 1 6. That's all I need. I need just 1 6. So with that done, I need to write out the factors that are here and also that are here. Okay, the factors that are common to both 24 and 36. That's the next thing I want to do. So I can see 1 and 1. 1 and 1 is common. Okay, so I can see 1 and 1. 1 and 1 is common. So you see the 1 coming out. You can also see 2 and 2. 2 and 2 is also common. So you see 2 and 2 coming out. I can also see 3 and 3. So 3 and 3 is also coming out. I can see 4 and 4. 4 and 4 is merging together and coming out. You can see 6 and 6. 6 and 6 is also coming out. Now, there is a 8 here with 24, but no 8 here. So it means that 8 is not common. Now, there is a 12 here, and I'm also seeing a 12 here. I don't know if you can see, but if you're watching the screen, you will surely see. So that's 12 and 12, and they are both are already making a common factor. So if someone asks you what are the common factors of 24 and 36, and the factors we have in 24 and the one you also have in 36, those are just the common factors of 24 and 36. So you have them to be 1, 2, 3, 1, 2, 3, 4, 6, and 12. So those are the common factors. That is the factors that 24 has and 36 also does have. Now, the next thing is let's look for the highest. What's the highest among them? Of course, it's going to be 12. The highest of these common factors. That's just what the H.C.F is. The highest of the common factors that you have been able to generate here. That is what you needed. So, and that gives 12. Alright? We've been able to get the highest common factors of 24 and 36. We'll need it somewhere, so you need to get it. Alright, let's look for more. Now we're having 50, 75, and 100. Okay, let's go further and let's write out the factors of 50. We're going to be having 1 and 50 because 1 divides into every number. Now we're going to be having 2 and 25, I think, because 2 goes in 50. 2 divides into 50. So that's 2 and 25. 3, does 3 goes? No. So remember, I've been using the paired number system. The paired number system, and I taught you how to use it. So you make a list of numbers and you select them one after the other in order of their size. You don't skip any. So you accept or you make use of the ones that divides directly without remainder, and you ignore the ones that doesn't divide directly. I hope that is understood. Now, the next number here is going to be 5, because 3 doesn't divide into 50 and 4 doesn't divide into 50. The next number here is going to be 5 and 10. Yeah, so this is 5 and 10. And after that, can we think of any other number that divides into 50? I think none. So these are the list of factors of 60, complete list of factors of 60. So let's take a look at 75. Okay, we can have 1 and 75, very sure. 2 will not be a very good factor of 75. Yes, because 75 is an odd number, it's not an even number. Let's see if 3 will work. Can you just do 75 divided by 3? What do you have? You can have 3, half 25. So this is 3 by 25. You're going to get 75. Okay, and after 3, 4 will not divide into 75, definitely. Then let's make use of 5. That's going to be 5 and 15. So 5 multiplied by 15 is going to be 75. So just take note of this piece of number as they're coming out. Their product is always what? 75. And any other number? I'm not sure there is any other. No. Okay. Let's work on 100. Now we have 100. That is 1 times 100 gives 100. Now we have 2 by 50. That's 2 times 50 gives 100. Then we have 4 by 25. Because 3 will not divide into 100. So we have 5 by 20. See them coming out rolling in. Sorry, you can have 10 by 10. It should be 10 times 10, but I just need a 10. not 2 10s. I just need a 10. Alright, with this done, let's see what are the common factors. I'm seeing a 1 with 50. I'm also seeing a 1 here, and I'm also seeing a 1 with 100. So I can just pick that one. So for the common factors, 1 is common. Okay, everything is coming out already. Now, let's just go through it one by one now. There is a 2 here. There's no 2 here. No 2 here. So it means that 2 is not common. Though 2 is there, but it's not common to the 3. It's not with 75. Now, 5 is there, 5 is there, and 5 is there. So 5 is also a common factor. That is why you see it displayed here. Now, this is 10, and no 10 here. But there is 10 here. So since 10 is missing here, that shows that 10 is not a common factor. Now, this is 25. This is 25, and this is also 25, as you can see. But sorry, please ensure the use of comma in your work, please. Ensure the use of, make use of comma. Here I was trying to say that 25 is common to the 3, like you can have 25 here, 25 here, and 25 here. Yeah. So, the highest common factor now, among these 3 common factors, which one is the highest? The highest will make our highest common factors. Alright? So that's 25. So, the common factors of the 3 are 1, 5, and 25, and the highest of them is 25. Okay, now let's look at the prime method. Wow, now this is just a method. I want to look at the prime method of looking for highest common factors of numbers. So we are still considering 50, 75, and 100. Let's express 50 as a product of prime. We want to write out 50 as a product of prime. So we're going to be having 2 by 5 by 5. 2 multiplied by 5 multiplied by 5. That is 50 expressed as a product of prime. Now, if you are not clear with this, I have a class on expression of numbers as a product of prime. You may need to be there. You may need to watch the video for you to have a full grasp of what I'm doing here. Now, here I'm having 3 by 5 by 5 for 75. For 100, I'll be having 2 multiplied by 2 multiplied by 5 multiplied by 5. Alright? That is what I'm having for 100. So, if that is done, then I need to consider 2 here. So there is a 2 here, but no 2 here. So this 2, there is nothing I can do with it now. 2 is not common. Okay? Now I'm seeing a 5 here, and I'm seeing a 5 here. I'm also seeing a 5 here. So I'm seeing 5 appearing the list of the factors. So here is a 5, here is a 5, here is a 5. And that makes the first selection of 5 that I'll be able to select. So, and that is represented by this. Now I'm having another list of 5. This 5, 5, and another 5. Making the second 5 I'll be considering. So that's why you see 5 coming out twice here. So the first list of 5 is this, and this, producing this. And the second one is this, and this, now producing this. I think by the use of my arrow, you should be able to get what I'm doing. Now, other factors are appear, or they're not represented in all the lists. So I'm only having 5. So my answer now gives 5 multiplied by 5. I'm having 25, just like I have it here. It's as simple as that. Now, let's consider more examples. Now, okay, here I'm considering 96, 160, and 120. Okay, so for 96, I'm having 1 and 96. I'm having 2 and 48. I'm having 3 and 32. And I'm having 4 and 24. I'm having 6 and 16. I'm having 8 and 12. So, as these numbers are coming out in pairs, when you multiply them, you're definitely going to get 96. Okay, that's the last pair, I think. Now, for 160, I'm having 1 and 160. I should be having 2 and 80. I should be having 4 and 40. Should be having 5 and 32. Should be having 8 and 20. I should be having 10 and 16. So, as these numbers are coming out in pairs, just multiply them together, you have 160. Okay, the last one, I'm having 120. So, 1 and 120 will give me 120. 2 and 60 will give me 120. 3 and 40 gives 120. 4 and 30 rolling in gives 120. 5 and 24 gives 120. You see 6 and 20 gives 120. 8 and 15, 120. And 10 and 12, whoa, it's giving 120. Let's get the common factors. I'm having 1 to be a common factor. I'm seeing a 1 here, a 1 here, and a 1 here. So that's 1. I'm seeing a 2, and a 2. So like you can see 2 coming out here. I'm seeing a 3 here. 3 is not here. So here, but it's disqualified already because it's not found there. I'm seeing a 4, and another 4. So that gives 4 the chance of appearing here. So this is a 8, another 8, and another 8. So that's why you see 8 coming up now. This is a 12, but 12 is not here. Though here, but it's disqualified already. This is a 16. 16 is there. I'm sorry for the modeling and for not using a comma. I'm so sorry for that. I'm so sorry. It seems I'm confusing people. Sorry. So 16 here, and no 16 is appearing here. I'm having a 24. 24 is appearing here. I'm having a 32 here. I'm having a 32 here, but I'm not having any 32 here. Oh God. This 48, no 48 here, no 48 here. This is 96, no 96 here, no 96 here. So, list of common factors I have for these 3 numbers are 1, 2, 4, and 8. Those are the list of common factors I'm having. I'm looking for the highest among them. What do you think that would be? Of course, that would be 8. So, the highest of them all is going to be 8. Please, I want to say again, whenever you want to make a list of your numbers, please make use of comma. That's very essential. Alright, let's proceed by using the prime system. So the prime system, writing 96 as a pair of prime gives this list of numbers. 2 by 2 by 2 by 2 by 2 by 3. Now 160 gives 2 by 2 by 2 by 2 by 2 by 5. For 120, I have 2 by 2 by 2 by 3 by 5. So let's try and see factors that appear commonly. So I'm having a line of 2 here. So this 2 is representing all these 2 multiplied by, this is another list of 2. Okay, and I'm having another list of 2 here. So this list is represented by this. This one is represented by this. And this one is represented by this. Do I have another complete number that is well represented? There is a 2 here, there is a 2 here, 2 is gone already. I can't use 2 again. And there is a 3 here, no 3 here, 3 is disqualified. There is a 5 here, there is a 5 here, but there is no 5 here. So these are just the list of numbers again. So that is how we make selection in the prime system. Now it's a bit different from this. So they look alike, but they're not just the same. If you make use of the principle I'm using here, you will definitely have the same answer. So like I'm having a 2 by 2 by 2. It's giving me what? 8. So I have the same 8 here. So if you can make use of the prime system, good. If you can make use of normal factors. Alright, we are drawing the curtain here for the end of Unit 1. I just want to believe you enjoyed the class. And if there is any question, please just drop it at the comment section. I'll be there to attend to your question. If you have any challenges and factors of numbers, get it across to me. We're going to solve it and look into it together. Now, there's going to be a classwork attached to this work. The link to the classwork is in the description box. Just make sure you get there and attend to the work. It will really help you. I mean, it's going to really help you. Alright? So, getting the Unit 2, just click on the next arrow.